Polly the polynomial penguin, back talking to you about factoring by grouping. Now here's a question. What do you call a snowman with a six-pack? An abdominal snowman!
First thing we're going to do is talk about the greatest common factor. That's the highest number that divides equally into two or more terms. So here you can see if we were to break down 40 and 12 into their prime factors, we see that each of them has two 2's as part of their prime factors. Therefore, 2 times 2, 4 would be the greatest common factor of 40 and 12. That means 4 is the greatest number that divides evenly into both 40 and 12. Now let's review the steps when factoring a quadratic expression. The very first thing that you want to do is look for a greatest common factor between the terms and factor it out. Okay, that's the first thing you should do every single time. Then you're going to choose a factoring method. We've talked about factoring with difference of squares, perfect square trinomials, and using the magic X. Today, we're going to talk about factoring by grouping. Now let's show how to factor by grouping. So to factor a quadratic expression of the form ax squared plus bx plus c by grouping, what you're going to do first, it might sound weird, but your first step is actually to make a magic X. So we're going to use the magic X, but in a different way. Our A value in this case is 1, our B value in this case is 2, and the C would be -8. So to make our magic X, we multiply A times C, that goes on top, your B value goes on the bottom. You then think about two numbers whose product is -8, they have to multiply together to make -8, and whose sum is +2. They have to add together to make +2. So two numbers that multiply together to make -8 and add together to make +2 would be +4 and -2. What we're then going to do, since we have used the magic X, our next step is to use the two numbers that we just found and split the bx term up here. So our original quadratic trinomial looks like this, right? It has a 2x as the middle term. What we're going to do is we're going to take the 4 and the -2 and we're going to split the 2x so that instead of being plus 2x, it's going to be plus 4x minus 2x minus 8. Okay, so we just took this middle term and split it. And if you look, 4x minus 2x still gives you 2x. So it's the exact same equation. We just rewrote the middle term as these two terms. Now what we can do is factor out the greatest common factor from the first two terms and from the last two terms. So if you look over here, our first two terms are x squared and 4x. So what is the greatest common factor between x squared and 4x? Well, they both have an x, don't they? So I'm going to put an x on the outside of a set of parentheses, and on the inside, I put each of these two terms divided by x. So that would be x plus 4. Over here, each of these two terms has a -2 that I can take out. So I take out -2, put it on the outside of a set of parentheses, and I divide each of these two terms by -2, and whatever I get, that's what I put inside the parentheses. Now, if you did this correctly, what's inside each of the set of parentheses should be the same binomial, and it is. So we can move on to step 4, which is to factor out the common binomial term. So technically, this is two terms, x and -2, both multiplied by x plus 4. So what I'm going to do is I'm going to factor out the x plus 4, and in another set of parentheses, I'm going to put our GCFs, x minus 2. And that's how you factor by grouping.
How did the penguin know something was wrong? It smelled a bit fishy! Example time.
Now, example 1, we're going to do the exact same thing. So first, is there a greatest common factor we can take out first? That's always your first step when factoring. No, there's nothing we can take out, so we move on to our next step. Let's create a magic X. When we're doing a magic X, we need to know what our A, our B, and our C are, because A times C has to go on top, our B value has to go on the bottom. We then think about two numbers whose product is 12 and whose sum is 13. So two numbers that multiply together make 12 and add together make 13. Well, that's easy, it's going to be 12 and 1. We then split our middle term. So the 13x, instead of writing plus 13x, we're going to write plus 12x plus 1. So it's going to be 2x squared plus 12x plus 1x plus 6. Sweet. Now we're going to factor the GCF out from the first two terms and from the last two terms. So our first two terms, what do they have in common? Well, I can divide each of those by 2, and they each have an x. So I'm going to take 2x, put it on the outside of a set of parentheses, and then divide each of these by 2x to get what goes in the parentheses. So if I divide this by 2x, I just get x. Divide this by 2x, I get 6. So x plus 6, that's what goes in the parentheses. Here, nothing really divides into each of these. If that ever happens, you don't just write plus x plus 6, you're going to write plus 1 parentheses x plus 6. We're going to factor out a 1 from each of these. It helps you because now when we're going to factor out our common binomial terms, since they're both x plus 6, we take that x plus 6, we put it in front, and in the next parentheses, if you didn't factor out a 1, you might be confused and just put 2x. But it's technically in the second set of parentheses going to be 2x plus 1. And it needs to be that in order to get what we had up here. Don't forget that you can always take your answer and FOIL it to check to see if you got the correct answer. If you FOIL this and get your quadratic equation up here, or your quadratic expression up here, that means you did it correctly.
What do you call it when a snowman has a temper tantrum? A meltdown! Wah, wah, wah. You try.
Okay, so again, we first start by looking for a GCF. Is there greatest common factor we can take out? No. So we move to our next step. Let's create a magic X. We need to know what our A, our B, and our C values are. We then take A times C, put that on top of the magic X. Our B value goes on the bottom. We think about two numbers that multiply together to make 42 and add together to make negative 23. Now, since we have positive 42 and negative 23, that means both of these numbers should be negative, right? Because a negative times a negative makes a positive, and they add together to make a negative. So your two numbers are actually going to be negative 21 and negative 2. And it's okay if that takes you a while to find. It sometimes takes a while to guess and check which give you a product of this and a sum of this. Now that you have your two numbers, you're going to split that middle term, that bx term. So here in this case, we're going to write 3d squared, and instead of writing minus 23d, we're going to write minus 21d minus 2d plus 14. Now that we've done that, we can factor out the GCF from the first two terms. So what can we take out from the first two terms? Well, they're both divisible by 3, and they both have a d. So we'll write 3d in front of a set of parentheses. And in those parentheses, we divide each of these by 3d. So this is going to be d. This is going to be negative 7. So it should be 3d and then parentheses d minus 7. Over here, each of these has a 2 that we can factor out. And if I want to make it so that each of these parentheses have the same binomial in them, I'm going to factor out a negative 2 instead of a positive 2. Now we can move on to our final step, which is to factor out the common binomial term. And since they're both d minus 7, we can take that, put it out front. And in the second set of parentheses, we put our greatest common factors, which would be 3d minus 2. Boom, done. Example 2, we're going to factor the given quadratic expression by grouping, so just the same. Here, is there a GCF we can factor out in the beginning? Yeah, it actually looks like there is now. So each of these terms has an n we can take out, and it looks like each of these coefficients is divisible by 3. So we can actually factor out a 3n in the beginning. So we're going to take 3n, put it on the outside of a set of parentheses, and on the inside we put what each of these terms is divided by 3n. Sweet! Now what we can do is take what we have in here, 4n squared minus 8n plus 3, and factor that by grouping. So to factor by grouping, our first step is to create a magic X. We then determine what our A, our B, and our C values are. A times C is going to go on top. Our B value goes on the bottom. We then think about two numbers whose product is 12 and whose sum is negative 8. So two numbers that multiply together to make 12 and add together to make negative 8. That would be negative 6 and negative 2. We then have our two numbers with which we are going to split our middle term. So instead of being 4n squared minus 8n, we're going to take that minus 8n and instead write minus 6n minus 2n. We then factor out the GCF from the first two terms and from the last two terms. So the first two terms, it looks like we could take out a 2 from each of those and an n from each of those. So we'll write 2n in front of a set of parentheses, and in those parentheses we write each of these terms divided by 2n. So that would be 2n minus 3. Over here, it doesn't look like either of these have anything that we could take out, so we take out a 1. And to make it so that these have the same binomial term in the parentheses, we're going to take out a negative 1. If we were to take out positive 1, it would be negative 2n plus 3, which is not the same as this. So that's why we take out negative 1 instead of positive 1. So because these binomial terms are the same, that allows us to move to our last step, which is to factor out that common binomial term and put our GCFs in the other set of parentheses. We can then finalize our answer, because this is not our answer. Remember, in the beginning of the problem, we took out a 3n, which means that needs to be in our final factored form for our answer. So we put 3n, then parentheses 2n minus 3, parentheses 2n minus 1. That's how you write your answer.
What did the serious penguin always say? It's no joke. Wah, wah, wah. You try.
Okay, so again, anytime you're factoring, look for a greatest common factor we can take out at the beginning. I think each of these terms is divisible by 5. So let's go ahead and take out a 5. So we put 5 on the outside of a set of parentheses, and on the inside we put each of these terms divided by 5. There you go. Now we can take this x squared plus 3x minus 10 and factor that by grouping. So to factor by grouping, our very first step is to create a magic x. We then determine what our a, our b, and our c values are. A times c goes on the top of the magic x, your b value goes on the bottom. We then determine two numbers that multiply together to make negative 10 and add together to make positive 3. That's going to be positive 5 and negative 2. You then use those numbers to rewrite your middle term. So we take that x squared plus 3x minus 10 and instead write x squared plus 5x minus 2x minus 10. Now again, this simplifies to this. So we didn't really change the problem at all, we just rewrote it a little bit. Now what we can do is we can factor out a greatest common factor from the first two terms and from the last two terms. So what do the first two terms have in common? They both have an x. So I'm going to take that x, put it out front of a set of parentheses, and in those parentheses I put each of these two terms divided by x, which would be x plus 5. Over here, each of these two terms, I can factor out a negative 2, and in the parentheses, I put each of these two terms divided by negative 2, so that would be x plus 5. Perfect. The binomials are the same, which means I can take the common binomial term and factor it out. So I take x plus 5, put it out front, and in the second set of parentheses, I put what's left, our greatest common factors, x minus 2. Now again, this is not your answer because at the beginning of the problem, we factored out a 5. So that has to be in your factored form. So we take that 5, tack it on the front, and you're done. Now example 3, we're still factoring by grouping, but instead we get a polynomial instead of a quadratic trinomial. So here, what we're gonna do is the exact same thing, we're just skipping the magic x. So our first step, as always, when we're factoring, is there a greatest common factor we can take out from each term? No. So we move to our next step, which is to take out the GCF from the first two terms. So what's the GCF of the first two terms? Well, each of those is divisible by 5, and they have two g's, so I can take out a 5 and a g squared. Inside the parentheses then, I put whatever's left when I divide each of those by 5g squared. Here, each of these two terms has a 2 that I can factor out, so inside I put whatever's left when I divide each of those by 2. Now, our binomial is the exact same, perfect, which means we can factor out our common binomial expression, so 2g minus 5 goes in front, and in the second set of parentheses, we put our GCFs, which are 5g squared and 2g. Boom. Here, in part B, same thing. First, is there a GCF we can take out of all of the terms? No. So we move to our next step, which is to factor out a GCF from the first two terms. So each of these two terms has a 2 and 2 y's. So 2y squared goes on the outside of a set of parentheses. We then divide each of those terms by 2y squared, and whatever we get, we put inside the parentheses. Over here, these two terms do not have anything in common, nothing we can divide out besides 1. So we take 1 and we put it on the outside of a set of parentheses, and inside the parentheses we put each of these terms divided by 1, which is the same thing. Now, the good news is that when that happens, we get a common binomial expression, 7y plus 4. So we take that 7y plus 4 and we put it out front. We factor it out. So it's going to be 7y plus 4 in the front. And in the second set of parentheses, we put our GCFs, which are 2y squared and 1. Boom, done. Next, again, factoring. The first step, whenever you factor, is there a GCF you can take out of all of the terms? Yeah, right? We can take out a 2 from all of these. So let's factor out a 2. So we put 2 on the outside of the set of parentheses, and on the inside, we divide each of these by 2 and put those. Now we can go on to factor by grouping. So we take our first two terms and we factor out the GCF from those. So each of these two terms has a 3 and 2 p's we can take out. So it's going to be 3p squared. And then in the parentheses, it's going to be 2p plus 1. Over here, each of these two terms, the only thing we can take out is a 1, so we do. And then in the parentheses, we put the exact same thing because each of those terms divided by 1 is just itself. Now, the common binomial expression, 2p plus 1, is what we're going to factor out. So it's going to be 2, and then parentheses, 2p plus 1. And then in the other set of parentheses, we put our GCFs, which are 3p squared plus 1. And that is how you factor this. Let's try one more. So here, first, is there a common factor that we can factor out right at the beginning? The greatest greatest common factor would, yeah, I think each of these terms has an r, right? So we could take out that r right at the beginning. So we do that, and then we can use our factor by grouping method. So here, these first two terms, what is something we can factor out of those? Well, we can factor out a 2 from each of those two terms and 2 r's. So it'll be 2r squared, and then in the parentheses, we put what we get when we divide each of those terms by 2r squared, which would be r plus 6. Over here, you can take out a -5 from each of these two terms, and when you do, -5r divided by -5 is just r, and -30 divided by -5 is positive 6. So that's how we get our common binomial expression, r plus 6. Now we go ahead and factor that out front, so it'll be r, and then parentheses, r plus 6, and then in the second set of parentheses, we put our GCFs, which are 2r squared minus 5. And that's how you do it.
What did the penguin hang over their baby's crib? A snowmobile! Wah, wah, wah. You try.
Okay, so again, we first look, is there a greatest common factor we could take out from each term? No. So we move to our next step, which is take out the greatest common factor from the first two terms. Well, we can divide each of those by 4, and there's 2 x's in each of those. So it'll be 4x squared, and then in the parentheses, we put whatever we get when we divide each of those by 4x squared. Over here, there's nothing really you can take out from each of these terms besides a -1. And when you do that, you end up getting 2x plus 3 in our parentheses, which is the exact same as what's over here. Perfect, we're doing it right. That means we could take that binomial expression, that common binomial expression, factor that out front, and then in the second set of parentheses, we put our GCFs, which in this case are 4x squared minus 1. Over here, first, is there something we can take out right at the beginning? Doesn't look like it. So we move to our next step, which is to factor out the GCF from the first two terms. So it looks like I could take out a 6 and 2 t's from the first two terms. And then in the parentheses, I put each of these terms divided by 6t squared. Over here, what can I take out of these two terms? Well, it looks like I can take out a -7. And why do I take out a -7? Because I need this binomial expression to match this one. So if I take out a -7, I get 4t minus 7 in here. If I were to distribute that, that's what I get up here. And these two terms match. Perfect. That's what we wanted. Now we take that common binomial expression, 4t minus 7, we put that in front, and in the second set of parentheses, we put our GCFs, 6t squared minus 7. Down here, is there a GCF we can take out right at the beginning? Yeah, we can actually take out, each of these terms has a v, and each of these terms has a 2 we can take out. So we take 2v, put it on the outside of a set of parentheses, and on the inside, we divide each of these terms by 2v. Perfect. Now we can move on to factor by grouping. So we go to our first two terms. We take out the GCF from those first two terms. So each of these terms has 2 v's and they have a 4. So we're going to put 4v squared on the outside of a set of parentheses. So it'll be 2v and then parentheses, 4v squared, parentheses, 5v plus 2. Over here, each of these terms has a 3 we could take out. So we do. And inside we take each term divided by 3. That's what you get. Now the binomial is the same. So we know we're doing it right. We take that 5v plus 2, factor it out front. So it's going to be 2v, parentheses, 5v plus 2. And then in the second set of parentheses, we put our GCFs, which are 4v squared plus 3. Here, lastly, we are going to first look for a GCF we can take out. Is there something we can take out right away? Yeah, a 4. Each of these terms is divisible by 4, so we go ahead and do that. Then what we can do is we can go on to factor by grouping. So is there something we can take out of these first two terms? Yeah, w squared. I think that's it, right? So we're going to put 4 and then parentheses, w squared, parentheses, and then what do you get when you divide each of those by w squared? Well, that's 11w minus 9. Over here, we have 11w minus 9. There's nothing you can take out of those, so we take out a 1. Now, we rewrite this. So, since we have a common binomial expression that we can factor out, we go ahead and do that. So it's going to be 4, parentheses, 11w minus 9. Then in the second set of parentheses, we put our GCFs, w squared plus 1. Now our word problem says a trunk in the shape of a rectangular prism has a volume of 6x cubed plus 38x squared minus 28x square meters. What expressions can represent the dimensions of the trunk? Okay, step 1 in the word problem. We're not scared. We can do this. Step 2, we need to define our variables. So what is the question asking? It says what expressions can represent the dimensions of the trunk? So dimensions of a rectangular prism would be like length and width and height, right? So we say L equals length, W equals width, H equals height. Okay, we can label those on our rectangular prism over here. There you go. Now, Anything else in the problem that we need to know? Well, yeah, it says the volume is 6x cubed plus 38x squared minus 28x square meters. Well, volume should probably be a variable too. So we say V equals the volume of the trunk. Now that we have all that, what we can do is we can write our equation. Well, what is the volume formula for a rectangular prism? Well, it's actually volume equals length times width times height. Now, we are trying to find each of these, and we're only given the volume, which we can now plug in. How do we find each of these? Well, let's try to factor this. So what's the first thing we do when we're factoring? Is there a greatest common factor we can take out? Yeah, each of these has a 2 and an x we can take out, right? So we take out a 2x at the beginning, and that means we have one of our dimensions. Well, can I factor this more? Yeah, let's factor this more. If we were to factor this more into two binomials, then we would have the length, the width, and the height. So let's do that. Here. In order to factor 3x squared plus 19x minus 14, what we're going to do is use the factor by grouping method. So we put a times c on top, put our b value on the bottom. We find two numbers that multiply together to make negative 42 and add together to make 19. That would be 21 and negative 2. You then split up your middle term. So instead of writing plus 19x, we're going to write plus 21x minus 2x. Now we can continue to factor by grouping, so we take these first two terms and we factor out the greatest common factor between those, which would be a 3 and an x, and in the parentheses we write what's left when you divide each of those by 3x, which would be x plus 7. Each of the two terms over here we can factor out a negative 2 from, and in those parentheses we write what's left, which is x plus 7. Now you see that we have a common binomial expression, x plus 7, that we can factor out, so it's going to be 2x, and then parentheses, x plus 7, and then in the second set of parentheses we write our GCFs, which would be 3x minus 2. We now have three terms multiplied together, which can technically give us our length, width, and height. We don't know which one is which. We don't have enough information for that. We just know that these three measures make up the dimensions of our given rectangular prism. So we say that the dimensions of the trunk are 2x meters by x plus 7 meters by 3x minus 2 meters.